basic trig substitutions that you can use in integrals that are a little more complicated. So to begin with, I'm just going to give you the basic formulas that you can use for the substitution, and then I'll go into an example. So first, I'm going to show you the first substitution that you can use. If you have the integral of 1 over the square root of 4 minus x squared dx, there is a trig substitution that you can use to make this simpler. If you see the form 1 over square root of a squared minus x squared dx, or even just the square root of a squared minus x squared, you can substitute x as equal to a sine of theta. Now I know what you're saying, this will probably just make it more complicated, but I'll show you in the example how this actually plays out. So if I see the form a minus x squared, and it's all on the square root, I can substitute x equals a sine of theta. And then, of course, as we know with u substitution, we'll have to find dx, which would equal to a cosine theta d theta. And I'll go into that in more detail in the example. But this is the first form that you will see. If you see this, you need to substitute x is equal to this. The next form I want to show you is if you see the form of 1 over square root of x squared minus 4 dx. Now this looks very similar, but you're going to use a completely different trig substitution. So if you see the form of 1 over the square root of x squared minus a squared dx, or even if you just see the square root of x squared minus a squared, you will substitute x is equal to a secant theta. And then you'll find dx, which would be equal to a secant theta tan theta d theta. And again, I'll go into more detail as to how you would solve this using this trig substitution in the example. But as we saw above here, if you see this form, you are going to substitute x equal to a secant theta. So the difference that we saw between these two is the placement of the x squared and the a squared. And a is just any constant. So in this example, 4 was our a squared. You saw the a squared, that's the 4. And then you take the square root to find the a, which is 2. So the a is just a constant. So if you see a number that is squared minus x squared, you'll see a sine theta. If you see the form of 1 over the square root of x squared minus a squared, you'll use a secant theta. And last one that you are going to see is the form of 1 over, I'm just going to use 4 for the simplification of seeing this visual, 4 plus x squared, or a squared plus x squared. And since it's addition, you may also see x squared plus 4, and that's the same thing. You can use the same exact trig substitution. So if you see the form of 1 over the square root of x squared minus plus a squared, dx, or simply the square root of x squared plus a squared, you are going to substitute x as equal to a tangent of theta. And again, I'll go into the exact details in an example to show you how this plays out. And then it's obviously solve for dx, which would be a secant squared theta d theta. And again, if you see this form, you're going to substitute x is equal to a a tangent of theta, excuse me. So now you have all three of your basic trig substitutions that you will use in this section. And you just look at the form that's inside, the form that's inside, and the form that's inside to see which trig substitution you're going to use. Now I'm going to go into an example, and I'm just going to use basic easy numbers so that it's simpler for you to see. So let's put example slide down. There we go. So if we have the integral, and it can be indefinite or definite, of, let's say, dx over square root 36 minus x squared. And this is the same thing as saying a squared minus x squared. I just use a different number, but it's the same thing. So if we look back at our formulas, we're going to use this one up here because it's a squared minus x squared. So as we saw in our formula from right up here, we're going to substitute x is equal to a sine theta. So then we'll just put our actual a in, and this over here is a squared. So to find a, you just take the square root of 36. So a is equal to 6. So over here we're going to have x is equal to 6 sine of theta. And obviously we need to find our dx, which would be equal to 6 cosine theta d theta. So that's the substitution we're going to make. We're going to zoom in here a little bit. This is the substitution we're going to make. So dx, which is 6 cosine theta d theta, all over square root of 36 minus our x is 6 sine theta, and don't forget that is squared. So if we simplify this a little bit, simplify the bottom of 6 cosine of theta d theta all over the square root of 36, and then I'm going to square this, so you have minus 36 sine squared theta. So I just squared the 6 and I squared the sine theta right here. And if we continue to work this problem out, we'll see that it goes to 6 cosine of theta d theta all over. I can factor out this 36, and I can put it right in this form. Parentheses. I can write in this form. Now, if you know your trig identities, you can see that this right here can simplify to the form of cosine squared theta. And now this might show you that, okay, now if I have a cosine here and a cosine here, that might simplify things for me. So let's say I plug that in. We go integral 6 cosine of theta d theta all over. We're going to do square root of 36, and I'll use this green color, cosine squared theta. Alright, now you have the square root on the bottom, so you can simplify this to 6 cosine theta d theta all over. Oh, look at this, it's going to simplify really nicely for us. 6 cosine of theta, because I just took the square root of 36 and the square root of cosine squared, and I got 6 cosine theta. Now this simplifies very, very nicely for us. We'll take the red for xing them out. This 6 can cancel out with this 6, and just because 6 divided by 6 would equal 1. And this cosine can cancel out with this cosine. So what we're left with is the integral. All this is canceled out, and all we're left with is this d theta. So you can write it as the integral of 1 d theta, or even the integral of just d theta. And as we know, the integral of d theta is just theta. So all of this is equal to theta. Now, I know what you're saying. Cool, we're done. Oh, plus c because this is an indefinite integral. I apologize. So I see what you're saying because you think we're done. But we started with an integral with the function of x. So we need to get our answer in terms of x. In terms of x. So if we go all the way back to the top, I'm just going to copy and paste this right here and drag it. I thought I was going to drag it down. Ooh. We're just going to rewrite it because that's not working. So if I bring that down and I just write it down here, I have x is equal to 6 sine of theta. Let's make sure that's right. Yes. And we don't need dx for this. So if this is what x is equal to, we want to solve for theta. So what I'm going to do, I'm going to divide 6 from both sides. So I'm going to get x over 6 is equal to sine theta. Then I solve for theta, so I just have the arc sine of both sides. X over 6 is the arc sine of sine theta. And if you know, this is just the inverse, so I can cancel this out with this. So I'm going to have the arc sine of x over 6 is equal to theta. Then we're going to plug this theta in for this theta to get it back into a function of x. So if we just plug this in, then we get arc sine of x over 6 plus c. And we are all done. This is our answer. So we started with this, and it was a little messy, so we simplified it by trig substitution that we learned above, and we got it down to our answer. And that is it for this video. In the next video, I'll go into examples using our secant theta substitution and our tangent substitution. But for now, I just did the sine theta. Thank you for watching, and please watch the other videos for more examples.